Welcome back, class. In our previous video we have discussed about the free electron theory of the conduction. In that topic we have discussed about the how the microscopic view of the conduction process, right now. So in that concept we have discussed about the concept of the free electrons, and as we found, when the potential difference applied across the conductor, then all the electrons will move in a certain direction, and because of that movement there is a net current flows through the conductor. Today we are going to discuss what is the relation between the drift velocity and the current. Right? This is very important term. In this topic you will understand the electric current and the drift velocity. What is the relation? How these two terms are related. So you just see here, suppose we have a conductor here. We have a conductor, right? And this conductor has some free electrons, random orientations of the free electrons, and I am assuming these free electrons are moving in this direction. With velocity Vd, right? Vd, that is the drift velocity. That means the average velocity of these free electrons is, I am considering it is Vd, and it is obvious when all the electrons are moving this direction, that means we have to apply some potential difference. I am assuming this side the positive terminal is connected and this side the negative terminal is connected. That is why the electrons are moving in this direction, right? So this end is connected with the battery, right? This is connected with the battery, then there is a potential difference built up, and because of that potential difference there is an electric field set up, and this electric field is forcing the free electrons to move towards this end with a velocity Vd, right? So this is the free electron model of the conduction. I am assuming, let assume the area of cross section of this conductor is A, right? And the free electron density on this conductor is N. So what is N? N is the free electron density, that means number of free electrons present in unit volume is N, right? So that is giving the population of the free electron in unit volume. So this N is basically representing the population of the free electron in unit volume, right? That is called the free electron density. So when the electric field set up, then the movement of the electron takes place. So at any cross section, right? Suppose at any cross section, the number of free electrons crossing at any cross section of conductor is equals to how much? See, that value will be N into A into Vd. N into A into Vd. The question is how this value is N A into Vd. See, number of electrons crossing at any cross section of conductor in unit time. In unit time is Na into Vd. How this value is? See, what is N? N is the number of electrons per unit volume. That means in the denominator volume is there. And A is what? Area of cross section. And what is Vd? Vd is the drift velocity. Right? So how much distance covered by the free electrons in 1 second or the unit time? Just see, if any particle is moving with the 5 meter per second, so how much distance covered by that particle in 1 second? It is obvious, it is 5 meters. So it is representing 5 meters per second is representing in 1 second the distance traveled is 5 meters. Similarly, what is Vd? Vd is the drift velocity, that is the unit is meter per second. So that means this Vd is representing in the unit time the Vd distance traveled by the free electron. Right? In unit time, the Vd distance traveled by the free electrons, right? In unit second. In unit second, the distance traveled by the free electron is Vd. So here see the product of A into Vd. A is what? The area of cross section. Vd is what? The length in 1 second. The distance traveled in 1 second, right? So A into Vd is a volume covered by the free electrons in 1 second. Right? A into Vd is the volume covered by the free electrons in 1 second. And here is N is what? Number of free electrons per unit volume. So A into Vd is also volume, and here also for the N there is a volume in the denominator. So both volume get cancelled out. So what you will get for the N? Number of free electrons. Right? That is why the statement C, number of free electron crossing at any cross section of the conductor in unit time. In unit time, in 1 second, is how much? N into A into Vd, because N is number of electron per unit volume, and A into Vd is also the volume covered by the free electron into 1 second. Right? The volume get cancelled out. You will get the what? The number of free electrons crossing at any cross section of the conductor in 1 second. So what is the value of the free electron crossing in t time? Simple, unit time with this value, then in t time this value multiplied by t. So number of free electrons crossing in t time is how much? Is equals to NaVd into T. Similarly, unitary method, in unit time this value, then in t time this multiplied by t. Right? So this is the number of electrons crossing at any cross section of the conductor in t time. I want to find what is the amount of charge is crossing in t time at any cross section of the conductor. So we know the number of electrons. The simple this number is multiplied by E, you will get the what is the amount of charge is crossing, right now? Because this value is what? This value is the number of electrons, free electrons. So electron has the charge of what? 1 electron has the charge of E. So we have this amount of the electron. So just multiply by E, you will get the number of the amount of charge is crossing in t time at any cross section of the conductor. So I am clearing this one. So the amount of charge crossing at any cross section of conductor in t time, right? In t time is given by is equals to how much? This is the number of electrons, just multiply by E. So how much you will get? NaVd into T, and this is multiplied by E. Right now? So this number just multiply by E, you will get the amount of charge. Clear? So this is the value of the amount of charge crossing in t time at any cross section of the conductor, right? And what is the electric current? Electric current is what? The electric current simple, which is represented by I, is equals to Q by T, rate of flow of charge. That means if the Q amount of charge is crossing at any cross section of the conductor in t time, then the value of the current is I is equal to Q by T. Now see, we know the value of the Q, right? Just put the value of Q here. So you will get I is equal to NaVd into T. This D is suffix, right? Vd into T and multiply by E and divided by T, right? So in place of Q, just put the value of this one. So here T and T get cancelled out. So after simplification, what you will get? After simplification, we will get I is equal to NEAVD, right? So this is our what? I is equal to NEAVD. Now see here, this is the relation in between what? In between electric current and the drift velocity, which is our aim, to find the relation between drift velocity and the current. So this is the relation between the drift velocity Vd and the electric current. Clear? So quite simple. So with the help of the basic definition of the drift velocity, we just found the amount of charge is crossing at any cross section of the conductor, and when you find the amount of charge, so by simple basic definition of the electric current, I is equal to Q by T, just put the value of Q and you will get the value of the electric current. So here this is a very important relation in between electric current and the drift velocity. If you know the relation between the electric current and drift velocity, so whether we can find the relation between the current density and the drift velocity? Yes, we can find, because so you know that the J is what? The current density J is equal to what? I by A, right? So you know the value of I is put here. So J is equal to I NEAVD divided by area of cross section. So area of cross section get cancelled out. So you will get J is equal to NEVD. Right now? So this is the relation between the current density, right? Current density and the drift velocity. So this is the relation between the electric current and the drift velocity, and this is the relation between the current density and the drift velocity. But you know that the drift velocity is also a vector quantity, and the current density is also the vector quantity. So whether it is a vector representation of the current density and the drift velocity, you see here, what is Vd? Vd is the velocity vector in the direction of the movement of the free electron. Right now, free electron is moving this side, so the velocity vector is in this side. But what is the direction of the current density? In the previous video, I have mentioned that the direction of the current density is in the direction of the movement of the positive charge. Right now, that means it is the opposite direction of the movement of the electron. So here the current density and the drift velocity both are the opposite vectors. So we have to write minus sign here. Right now, this minus sign indicates the drift velocity and the current density vector are opposite in direction. Right now, opposite in direction. So here the current density J is equal to minus NEVD. Right now, because Vd is in the direction of the movement of the free electron, while the current density direction is always in the direction of the movement of the positive charge. So this is your vector representation of the relation between the current density and the drift velocity.